Container diagrams. C4 model level 2 is the container diagram. We have seen how context diagram work. We identify the actors, we identify all the external systems that are useful, and then the internal system or the system in scope that we are going to build. So context diagram revolves around these factors. While coming to container diagrams show the high level shape of the software architecture and how responsibilities are distributed across it. It also shows the major technology choices and how the containers communicate with one another. It is a simple, high level technology focused diagram that is useful for software developers and support or operation staffs alike. So the focus will be more on the system in scope and how the items inside the container diagram will be communicating with each other, and those items are called containers. So container diagrams talks about this particular piece, which is system in scope, and all the containers identified inside the system and how they communicate with each other is what we are going to discuss in the container diagrams. So like we discussed, container diagram zooms into the system in scope and how the containers communicate each other. Containers are part of the system. Okay, some of the examples that may be considered as containers are client-side desktop application. Examples of client-side desktop applications are like Windows desktop application written using WPF, and OS X desktop application written using Objective-C, a cross-platform desktop application written using JavaFX, etc. So anything which is related to such kind of development are considered as client-side desktop application. Each application may have different kinds of needs, and according to those needs, containers are identified. It is not necessary that all the systems that are being developed will have all these containers. It may have one or more of these containers. Okay, so that is client-side desktop application and client-side web application. A JavaScript application running in a web browser using Angular, jQuery, React, etc. And then server-side web applications, a Java WE web application running on Tomcat, an ASP.NET MVC application running on Microsoft IIS, etc. So all those server-side web applications where APIs are exposed and used by the client-side web applications. And then we have containers like server-side console application, a standalone application, a batch process, etc. All those will be part of the server-side console application. And a mobile application, an Apple iOS app, an Android app, a Microsoft Windows Phone app, etc. All those will be part of mobile application. For example, in internet banking system, we do have a client-side web application which will be interacting with client-side web application, and also we will have a mobile application where it will be user-friendly and easy to use for the customers. So for internet banking system, yes, these can be considered like client-side web application, server-side web application, mobile application, and then serverless functions. Serverless functions are like Lambda, which runs all alone, and then content store. Content store is like a blob store or a content store which will be useful to save the static content where we don't need to go to server to fetch those. So it will improve the performance of the application. And databases like Oracle, MySQL, and then file systems, and then shell scripting. So all these will be part of containers. And like I said, all these may not be part of every application, but one or more can be part of the application. So now coming back to our diagram, like we discussed, the focus will be more on the system that is going to be developed. So we will be working on that to identify some containers and how they interact with each other. So we are just trying to move these external systems that are identified so that we get more space for this system to draw those containers. So if you see here, we are not changing anything outside it. Maybe there will be some relation changes, but we are not changing any boxes, any external systems or anything which are identified earlier. So only we are working on the internal part of the system that is in scope. For a banking system, like we were thinking, there will be a web application. Web application, and then we may have a static store where we don't need to reach backend, and then we'll have a server side which is backend where all the APIs are written, and then we have databases, anything MySQL or anything, one or more databases. For simplicity, we'll leave it for one. And now the interactions between them, so how they interact with each other. So static content is delivers on the web application. All the static content will be shown in the web application itself, and web application will be interacting with the server side for all the API calls, requests and responses, and server side will be interacting with the database to fetch all the details from the database, reads and writes data to the database. So this is the internal, this is the system that is under the scope. So when we get to this point, there will be small changes in the relation. I mean, it will be little elaborate. For example, here we have getting account info. We'll remove this, and then we'll have two relations coming up. One is with the web application where the UI loads the UI, and we'll have another relation with static content loads UI and also addresses dynamic queries. And whereas with static content, it will be loading UI where you don't need to go to the server side for dynamic content. Okay, and then server side. This arrow we can extend this now because we know the specific container it is going to work with. This and move on. So now backend will be taking the in charge of sending the messages and emails to our service. And service will, this relation doesn't change. Email service will be sending the details to actors. So that doesn't change. So if you see here again, once again, our relations change a little bit because we are getting more granular relations here. Earlier we had only one relation where we said it gets information, but now from static content it is loading the UI, and from web application it is loading the UI and as well as any dynamic queries like the statement information or any queries that may come up from the customers. And if you see the interaction inside, web application looks for the static content to be loaded into it, and again it depends on the server side or backend application to get the requests and responses, which server side will be helping in reading and writing data from database and then serving it to the web application. And this relation is directly now mapped to the server side because server side our backend application will be responsible for sending all those emails or messages or alerts notification to the email service, and email service as usual will be sending it to the actors. And if you said this is about the container diagram. Hope it is clear. If you have reached to this point, I would assume that you are interested in this video and you liked it. So please give a like and share with your friends. Leave a comment for me if you need any other video or if there is any feedback for this video. Thanks for watching.